Let's talk about what powers mean. So here we are in section 10.2. Let's talk about what powers mean. So if you put a little number in the upper right-hand corner, you all know what that means, right? What does 3 with a little 2 up there mean? Yeah, it means 2 times multiplied, right? It means 3 times 3, which is 9. If you put like a 3 up there, we all know that means 3 of them. 3 times 3 is 9, times 3 is 27, etc. So how in the world would putting like a fraction up there, like, I don't know, 7/9 or whatever, are you saying that swings around into the hook like that?
Yeah, sure.
That is what I'm saying. And I'm saying it's got to mean that. They didn't make it up. They followed perfectly, logically, what they'd already made up. That's a big claim. You hear what I'm saying? I'm saying if you, now math makes up some things, and then once they make things up, they perfectly, flawlessly follow logically what they originally decided. So originally it was decided, purely made up. No logic there. The little numbers in the upper right-hand corner mean repeat symbols, right? That's what they are basically, right? A little 2 in the upper right-hand corner means repeat twice, 3 times 3, right? Once they decided that, everything else flowed logically. What do I mean? Can I prove that claim? Yeah, I can show you in a way where you too will agree. Think with me about the rules when you have like x squared times x to the third, say. What does that have to equal? Yeah, what is x squared? 2 of them. What is x cubed? 3 of them. So how many you got? So what's the rule? What do you do with the 2 and the 3? Because they feel like making that up, or because that has to be logically based on the fact that this means 2 of them, this means 3 of them? Logically, right? They're not making that up. They made up the original definition, but once you made up the little numbers in the upper right-hand corner mean 2 of them and 3 of them, you've got to add those powers. That's a clear, logical consequence, isn't it? Okay? Stay with me. I'm going somewhere. So, by that same rule then, what would x to the half times x to the half, same rule, stay with the same rule, have to equal? What's the rule? What do you do with the powers? Add them. What's this going to be? X to the whole. One whole, right? Half and a half, got to be a whole. Got to be true, right? See how we're just going logical here. We're not making it. We just saw that you got to add the powers. Same basis times you got to add the powers. No matter what numbers, right? It's true for 2 and 3. It's got to be true for half and a half. Okay, so what? Well, try that with plain numbers now. Try that with like 3 to the half. Oh yeah, let me make sure I'm consistent with you. So one more time. What's x to the 2, x to the 3? X to the 5. So what's 3 to the 2, 3 to the 3? 3 to the 5th, not 9 to the 5th. Why not? Well, because what does this mean? 2 3s. What does this mean? 3 3s. How many 3s you got? 5 of them. Not 5 9s. 5 3s. True? I'm not making stuff up, right? That's just, this means 2 3s. This means 3 3s. We got 5 3s. Not 5 9s. Yeah, but 3 times 3 is 9. I know, and you know. 3 times 3 is 9. But we are not multiplying 3 times 3 there. We're multiplying 3 squared and 3 cubed, which is 2 3s and 3 3s. That's different than just 1 3 times 1 3, huh? Right? Isn't that true? Okay. Now let's get back to what we were talking about. So what is x to the half and x to the half again?
X to the 1.
Got to be because you add the powers. Okay, now let's stick in a 3. So what's 3? Or let's do a nicer number. Let's do 9. What is 9 to the half times 9 to the half?
9 to the 1.
9 to the 1. It's got to be. Right? Again, you don't multiply the base, just add the powers. Keep the base the same, add the powers. That's the rule that must flow logically, right? You with me? We're about there. We're about there. So, suppose you had no idea what that weird half-power thing is. Maybe you didn't, about 10 minutes ago. No idea in the world what that weird half-power thing means. Well, wouldn't you agree from this true statement, we've all agreed this is true, that whatever 9 to the half power is, it times its times, right, times its very self equals what? 9. What number times its very self equals 9? What number do you know times its very self that equals 9? 3, right? Isn't 3 times 3 9? So that means this, 9 to the half, has to be what?
3.
Has to be 3. So what is that half power doing to the 9? What do you do to a 9 to make it 3?
You cut it in half.
You cut it in half, it's 4.5.
Oh. You square root.
You root it. You root it. My point is made, I hope. Did you see it? That half power has to mean a root. Yeah, that 2 swings here, the 1 is there. That's what it's got to mean. Do you see how they had no choice? They're just flawlessly following logically what it means to put little numbers in the upper right-hand corner. See how that's got to be? Do you like that? That's the kind of reason I like math. I know that might seem weird. I love a clear, perfect, logical thought that follows beautifully, step by step by step. I enjoy that. I think that's great. I think it's neat that logically you can conclude this has to be. This isn't just somebody's opinion. Politics, they bore me to death. Because, one person has an opinion, another person has, who cares? I mean, they matter and everything, but, I'm not going to, put my life into it because it's just people's opinion, and that changes over time, right? But this is true. That's the truth. No matter what we think of it, it is true. It logically flows. So, that half power must mean a root, right? Because what else times itself is 9 but 3? And if you're telling me 9 to the half is 3, you must have just rooted that 9. That half power is a root. So you see what that half power did? The denominator swung in there. And the 9-1 just stayed 9-1. Square root of 9, 3. Yeah. And we could prove it. Yeah, that's enough proving it. We better get to the homework. I hope you enjoyed that. But now, no more fun. Back to the homework. All right. So so let's get to the homework now. Now that we know that rule, what's 100 to the half power? What's it got to be?
100.
Yeah. That 2 swings around into the hook, and the 1 stays where it was at. So the top number in the power, the 1, stays put. The bottom swings into the hook. You tracking with me? So what's square root of 100? What's square root of 100? 10. 100 to the half power has to be a 10, doesn't it? It's true. Nobody's opinion. It's the truth. Okay, now having done that, I want to also let you know how to do it with your calculator, because that'll be easier. When it's pure numbers, let's just hit the buttons on the calculator. Now, we need these rules too, though, because there'll be letters in a minute. But if it's just numbers, let's just hit the buttons on your calculator. 10 is the answer. But let me show you how you would do it with your calculator. So you guys have your calculators? 10 to the power. Now the power button is different for different calculators. It's up arrow, or it's X to the Y, or maybe X to the blank, or maybe up arrow. And then you got it for the half, you have to, well, again, it depends on your calculator. You got to go 1 divided by 2. And you might have to put it in parentheses and then hit equals. So if you have the nicer kind of calculators that show like it shows something at a higher level, then you don't have to worry about the parentheses. Those are nice. It knows the half is up there. It's all good. So try it out. Try 100 to the half power, hit equals. Should be 10.
No.
100. Right, so you'll need parentheses, yeah. So some of you will need parentheses around that half. So open parenthesis, 1 divided by 2, close parenthesis. So how do you know? If it's all on the same level, if it puts it all in on the same level for you on your calculator, then you will need parentheses. Let's make sure we're all doing this, because the next one, so do the next one. Oh yeah, that's kind of a hard one. The next one, see how that 1/4, I'm going to give 2 of them and then I'm going to bounce around, make sure you can all do it. So next one, we'll have 2 of them on the board. It's a fraction, so just put the 1/4 power on the top number and on the bottom, right? It's on both, right? That 1/4 is on the whole parenthesis, so it's on the top and the bottom, right? And then just do both of them. You should get 1/3. So just do both of them separately on your calculator. Am I making any sense? In other words, go 1 to the power, 1 divided by 4 equals. And on the bottom, go 81 to the power, 1 divided by 4 equals. And you should get 1 on the top and 3 on the bottom. That are pure numbers literally follow that order. That exact order really will work. It'll give you the answers. And what do they want? Rewrite, use radical notation. Yeah. Okay. Rewrite as a radical. Okay, so they're giving me, so basically, what they're wanting me to do now, they want me to rewrite that as a radical. What's a radical? Someone with extreme political views. No. It's a square root. It's the word for root. So basically, they're wanting me to do this. So right here, or if you have the rule right there, we're translating between two languages, like one and uno. Right? One and uno. We're saying the same number in two different languages. That's what we're doing with fractional powers and roots. These are saying the same thing in two different languages. Fractional power language, radical language, it's called root language. So they're going to have a whole bunch of problems where we just practice going back and forth, back and forth. They want to make sure we're comfortable translating between those two languages. So here it is in fraction power language. Now they want me to say it in radical language. Rewrite it, say the same expression in another language. So how do I say it? Well, you know what's going to happen, right? The 5, right? What does the rule say? The D, it's only the bottom. The top stays put, the fractional power. The A stays up there. See, the A doesn't go anywhere. X to the A, that hasn't gone anywhere. But the denominator, that swings into the hook, doesn't it? Good. Now, here's the trick, though. They're trying to trick you on this one. Let me ask you this question. That 1/5 power, is it on everybody or just on the M? And how do you know? There's no parentheses. He's just on the M. He's not the 3's power. If there were parentheses like that, then he'd be everybody's 1/5 power, wouldn't he? So what? Well, he's only M's power, right? He's not on the 3. So the 3 ain't doing nothing. The 3 is just going to sit there. And now when we make our swing around change, the 5 will swing around only the M, not the 3. So it'll become that. And we're done. Does that make sense? That 1/5 power is only on the M. Now, if there were parentheses, then that 5 would have swung around and the whole 3M would be inside the root now. But it's not, because that 3 was never under the power, so he's not under the root. He's just a spectator. He's just watching. That makes sense? So they're trying to trick you. Watch out. And that's all they want. They just want me to change it from fraction power language to root language. Denominator swings into the hook. Done. Number 4, negative 64 to the 1/3. Negative 64 to the 1/3. Now, are there on number 4, are there any letters?
No.
So what should we do? Just use your calculator. When there's no letters, just hit the buttons on your calculator. Do you know what I mean? Just crank it. Now, there's parentheses on that minus 64. So you're going to need to put parentheses on that minus 64. The answer should be negative 4. See if you can get it on your calculator. Yes, the nicer ones you don't. But it's always safe to put the parentheses. So you should be able to get, I'll write down the exact buttons you would push. You would go parenthesis, well, negative. Here, let me suggest, because the negative is such a pain, how about this? Forget the negative. You know the answer is going to be negative. Just, you know it's going to be negative. Don't even type it on your, and just on your calculator, just go 64 to the power, which is either going to be an up arrow or a y to the x, and then parenthesis, on some calculators is needed, 1 divided by 3 equals. And you should get 4, and then you know it's negative, so throw the negative back in front. I think it's easier to just deal with signs yourself, because calculators can be a little touchy about all that. It's just negative.
Okay, but if you were to put the negative on the 64, would you have to do parentheses on it?
It depends on the calculator. Okay. So that's why I just don't want to go there, because on some it does, and some it does, and some of them the negative is done after, some before. I mean, I'm glad to help you. Come up individually, but there's not a lot of help I can offer to all at once with that. My best help is to say, just forget. I don't even deal with negatives. Can be a pain on some calculators anyway. They can be a big pain. Just do the 64, and you know the answer is negative. That making sense? You're able to get that in your calculator? 64 to the 1/3 power? I mean, you could do it by hand if you want to. I know some of you don't have a calculator with you. You can do it by hand. You just go 64. What does that 3 do? Swings around into the hook. Like that. You know it's going to be negative. Right? So that 3 just swings in the hook. It's the 3rd root of 64. So in other words, it's asking what times itself 3 times is 64. That's what a 3rd root does, right? Like a square root asks what times itself twice. Like the square root of 9 is 3 because 2 3's multiplied by 9. So what times itself 3 times? You can just guess on your calculator. You'll find it's 4. 4 times 4 times 4 is 64. So that's why the answer is negative 4. So that's by hand. Easier to just do it by calculator. All right. I better see if you can get a 32 there. You can do it by hand as well if you want.
House or
I'm sorry, what's that?
to write the number feed the 16 5/4 the power?
Oh, they just want the answer.
They just want the answer. Don't know
Yeah,
how to-
they just, not, the only time they're going to want rounds if there's letters. If there's letters, yeah. So on this one, what they'll say is they'll say, well, they say use radical notation, but they want you to simplify if possible, and it's very possible. It just becomes a number on that one. Now, this one's got a trick. Are we ready? You guys have your calculators? Can anybody do the negative? Actually, do the negative on your calculator? It should be an error.
minus
An error?
Yeah.
so
What?
This one should.
4 to-
Oh, yeah, my getting
Oh, they said my
Yeah.
error.
You've been getting lucky up to now. It's not really taking in that negative when you do it that way. You got to put parentheses around that.
Yeah, negative
They
27.
give me error.
Yeah. So you do have to put parentheses around that minus 81
Okay.
to get the truth. And the truth is that this is not possible. This is an error.
Minus.
I'll give you a good reason in a minute, but let's see if you can get any calculator. Yeah, you got to put that parentheses, that negative 81 in parentheses, and then it should tell you error. Domain error. Correct.
Domain.
There we go. Now we're getting the good errors. Now, why? Why in the world?
Error.
Why can't you? We could do the others. We did another negative one a minute ago. Why was this one so fine? And I just said the answer is negative, and now we're having a big negative problem. What's the difference?
The bottom's even.
Yeah, you know that. I'm impressed. How do you know that? What's the story there?
I have no idea. I just literally figured this out as I'm going.
Okay, good observation, man. That is math. I mean, it's looking at patterns, and that's math. You're totally right. The problem is the bottom is even. If the bottom is even, then you can't have a negative power in there. Now, why? Why in the world? Well, think with me for a minute. What's the square root of 9 again? Let's go back to basic square roots. It's 3. If a young child was to ask you, why in the world is square root of 9 3? What are you doing? You would say to them, don't bother me, kid. No. You would say to them, 3 times 3 is 9. 3 twice is 9. 3 multiplied twice. Now, where's the 2 coming from? Why 3 twice?
Because the square root is always 2.
Because there's a 2 in the hook, really, right? When there's nothing in the hook, there's a 2. You tracking with me? And that 2 is the same as 9 to the half. Right? Remember the denominator swings in the hook? I'm going somewhere. You tracking with me? You staying with me on this ride? Okay, so what? So what's the square root of negative 9? You cannot do it. Because no number times its very self is negative 9. Right? What times itself is negative? Is negative 3 times negative 3? Negative 9? No way. That's 1 positive, 1 negative. Well, I'm sorry. That's 2 negatives is a positive. I'm thinking of the next one I'm going to try. Can you do 1 positive times 1 negative? No, because that's not the same thing times itself. That's times the opposite. So in other words, there's no number times its very self that's negative 9. That's why the square root of negative 9 is an error. You can't do it. Okay, so what? What's in the hook there? What's in the hook when there's nothing? 2. Which means that negative 9 is to the half power. You see the problem? When the denominator is even, that means the number in the hook is even. That means you're asking for something to multiply by itself an even amount of times and come out negative. That can't happen. Whereas odd, you can do that, right? Think with me. what's the cube root of negative 8?
Minus 2.
Yeah, because minus 2 times minus 2 times minus 2, 3 negatives goes back to negative, doesn't it? So that's totally fine. So do you see how it's okay to have an odd root of a negative number, but it's not okay to have an even root? And that is the denominator when you swing it back into the fraction, isn't it? So I bet many of you are like, can you just give us a rule here? I will. So here's the rule. If you have, it's the easiest way to write this out. So if you have a negative number to an a over b power, if b is even, then it's not possible. So there it is. If you have a negative and b is even, it's not possible. Because that's, swinging around, that's an even root asking for a negative answer. You can't do that. You can't multiply something an even amount of times, 2 times, 4 times. Even amount of negatives is positive. It's not going to come out negative. That's what your calculator's telling you there. Is that good? These little root rules get a little tricky. All right, let's move ahead. If you got that rule down, it'll be on. So they want us to take this and write as a radical. So this one has letters, huh? So I can't just, do it on my calculator and get a number. It's got letters. So what do I do to write this as a radical?
Throw the hook.
Let that denominator swing around, huh? Let that denominator swing around. Let's see that 5 just swings into the hook here. So it'll equal the 5th root. And the whole 7x plus 5 is in there all to the 4th power. The 4 stayed put, huh? The top of the fraction always stays put, doesn't it? We don't move that anywhere. It's just the bottom of the fraction that swings into the hook. Does that make any sense? That, the top stays put. We're done. That's all they want. That's all we can do. Because we have an x this time. We can't get a number on our calculator. Is this making sense? So if they give me just numbers, I use my calculator and get an answer. If they give me letters, I just swing the denominator into the hook, and I'm done. All right. Number 8, 64 to the minus 5/3.
Mr. Aaron,
Yeah.
and you cannot distribute the 7x plus 5? No, huh?
No, yeah, good question. No, it needs to stay just like that. It's because of the plus sign. Yeah, it just stays just like that. Good question. All right, so now number 8, you could just do it. It might be hard. Let me do one. I think it'd be easiest to do one by hand step. Notice the negative is in the power zone. That's very different than the negative being in the front middle base zone. That's a different world. So that negative is in the power zone. Do you remember how we had it previously? I think we have, haven't we? Forget. What is a negative in the, like if you just have like a, I don't know, a number like, whatever, 3.
But it does a negative power?
Yeah, what does a negative power do? Exactly.
It goes less. It go from big to less. Instead going bigger, it go less.
There are, you might be thinking of exponential functions. Just what is 3 to the negative 2 power?
3 to the negative 2 power?
It flips it to the bottom. Have you seen that before?
Yeah.
It's 1 over 3 to the positive 2. Do you remember that? Negative powers flip things to the other side. I can't remember. Have we talked about that or not?
But
No?
that wasn't 61.
61, was it? So negative powers flip to the other. Yeah, they're unhappy.
Yeah.
Yeah. Yeah, that's my analogy.
you put 1
I'd say it's, right, I always say it's unhappy. It's negative.
Yeah.
Where it's at, it wants
see.
to jump. So like somebody's unhappy
It
with
was
their
3,
job,
and then
they
become
want to
1.
jump to the new job. So there's,
It's less.
let me write that
It's
rule
less.
up. So we have 2
It become less.
rules going on now. So let me write them both for you, and then I'll put them up on the board too to help. So here we go. X to the negative power flips to the bottom and then becomes positive. And x to the fraction power, the b swings around into the hook. So those are two different rules which are simple. What's this going to do? This is 1 over 64, and then the power will jump to the bottom and then become positive. You tracking with me? So everybody see what happened? I haven't done anything else yet. I just said, hey, negative powers are negative, they're unhappy. And you jump to the bottom, and then the power becomes positive. And now, it's just numbers, right? Hit the buttons on your calculator. So I would do the negative part by hand, and then I would just hit the buttons on the calculator, and I don't know what you're going to get, 4 to the 5th. Oh, it's 1,024. The bottom should become 1,024. We getting that okay? So I just did, notice what I did. This is what I'm suggesting. I did the negative part of the power by hand. I let it jump to the bottom. And then the power became positive. And then I just hit the buttons on my calculator. You could maybe do the whole thing in the calculator. Some calculators can handle it, some cannot. Depends on the calculator. So that's why I'm doing part of it by hand. I know you can all do the rest. I know that's a surefire way everybody can do it. If you have a real nice calculator, you could just do the whole thing from the beginning probably. But it depends on your calculator. Is that good? Is that okay? So 2, and in a minute we're going to do letters anyway, so we need to know the rule. So negative powers are unhappy where they're at. They jump to the other side and become positive. Fractional powers swing into a root. All right. Okay. Well, now what does it say? Write with positive exponents. Simplify if possible. Think about, don't hit anything on your calculators. Don't write anything. I mean, you can write the problem down. Just think for a second. Think about the rule I gave you. Look at that denominator and that power. Is that denominator even or odd? Even. So what? Why am I making a big deal out of that? I don't know if you can all read it. It's negative 25 to the negative 3/2. This is even, and this is negative. So in other words, we have a negative number to some power where the bottom, whatever, some number, who cares, over even.
It's not possible.
Yeah, back here.
Not a real number.
Negative, and if that bottom is even, not possible. Remember? They're trying to trick us. Not option B, not a real number.
So save all the work.
Just say the word. Yeah, that's all you got to do. There's nothing to do but say it's not real. You cannot have a negative number in the parentheses and an even denominator because, remember, that's an even root on a negative number. That's not possible. You can't multiply something an even amount of times have it become negative. It's 1, let me make it a little bigger, 1 over p to the minus 6/7. Now, at this point, you really need to read the words. You know, a lot of times in math, we don't really even pay attention to the words, don't need to a lot of times. But here, really watch what they're saying, because they could ask you to go different places, and they will. What do they want? Write with positive exponents. Exponents are powers, right? They say, hey, make the powers positive in the end. So in other words, there's nothing in here about radicals. They don't care about square roots at all. They're not asking me to do anything with square roots, are they? Nothing about radicals. They just say, hey, we don't like negative powers. And pretty much that'll always be the case. We never leave negatives in the power zone. We always let them do their thing. Now, what is their thing? What do they do? I know the rules are coming at you fast here. Negative powers are negative. They're unhappy where they're at. They jump to the other side. Now, this one's already in the bottom. So he's unhappy in the bottom. So where's he going to jump? To the top. This whole thing is going to jump up top. And then after he jumps, he's happy. And the one's down below, but we don't leave ones in the bottom. Dividing by 1 does nothing. So the answer really is just p to the 6/7. Done. Is that making sense? So all that happened there was the negative power was negative, unhappy on the bottom. It jumps up to the top and becomes positive. They could have asked me to make it into a root, and then I would need to swing the 7 around and stuff, but they're just not asking for that on this one. See how they never said write it as a root, write it as a radical? They just said make power positive. I said, okay, there you go. There's your power positive. It's happy now. It jumped to the other side. Number 11. All right, rules. Yeah, hey, we just reviewed those. Remember, what's the rule when you have same bases multiplied? What do you do with those powers? Add them up, right? Remember, we just looked at that one? So here, let me get a little fresh room here. Was that b to the 1/3, b to the 4/3? So b to the 1/3 times b to the 4/3. Yeah, you just add them up. And that's going to be what? B to the 5/3. Done. Same bases multiplied, you add powers, huh? Remember that rule? That's like, just to make sure it's making sense for you, that's like x squared times x cubed is x to the 5th, right? Powers add, you know those rules, right? That's all we did there. It's just with fractions. They're just giving us the same old rules, but with fractions now. That's their game. Okay, so what do you got to do? You got to, get a right. Yeah, the only way to add those two we got to add the fractions, right? Add the powers. And the only way to do it is with a common denominator. Yeah, can you get a common denominator there? It's going to be 10, huh? Can you add them up that way? Make them both 10. One of them already is. Make that 3/5 become something over 10. Yeah. Right, we got to get common denominator there. So I'm going to multiply top and bottom of him by 2. So that's 6/10 and 1/10, 7/10 done. We okay there? So it's the same rule. Two same bases multiplied, powers add. It's just a little more work to add those. Questions? We good so far? All right, you all stop me if you have questions. Number 13. Okay, use property exponents. Okay, to simplify, write with positive powers, blah, blah, blah. Okay, so, okay. So, it's 16u squared all to the half power. All right, so they want me to do some of the rules we've been learning in this section. So what is that half power going to do? What have we learned fractional powers do? That denominator, the top stays put, the top of the fraction stays where it's at, the bottom swings into the hook, doesn't it? So let's do that for starters. So this 2 is going to swing into the hook, huh? And the 1 will stay put. Now that 1's not doing anything, is it? 1 power, that's just nothing. So I'm just going to say this is just the square root of 16u squared. That 1 power is not doing anything, right? Now, can I go further now? Yeah, what's the square root of 16? 4. And what's the square root of u squared? Regular u. Remember that whatever number's in the hook, that's the deal. Have we done much? Is that do we do the 2-for-1 deal stuff? We did in here. Did we talk about that? I'm sorry, I forget. I have another intermediate that I was teaching at Fresno City, and I forget. They're like slow, a little bit different pace, and so I forget what I've said in which thing. So we did do the 2-for-1. So let's just do it that way then. So this is the square root. This is the square root. This is 4 times 4 times u times u. Right? 4 times 4 times u times u. And right, the 2 in the hook, remember that makes everything a 2-for-1 deal at target? I did talk about that? Is that right? So 2 4s in, sends 1 4 out. Right? And 2 u's in, sends 1 u out. If you can see my 4's look like u's. So the answer is just 4 and u. Done. Or you could just say the square root of 16 is 4. I mean, I'm being more formal about it all. But, right, square root of 16 is 4, and the square root of u squared is u. If you can just see that, great. If you want a more formal explanation, it's because the 16 breaks down to be 4 times 4, and the u squared means 2 u's. And whatever number's in the hook, that's the deal at the store. Right? Remember that? So if there's a 2 in the hook, it's a 2-for-1 deal. 2 4s in your cart. You go out of the store only paying for 1. They're on sale 2 for 1. 2 used in your cart. You go out of the store paying for only 1. Right? 2 for 1. Done. Is that good? So what did we do? The fraction turned into a root, and then we did the 2 for 1 root for you. Questions? It'll be a little harder. X to the 7. Okay, so number 14. X to the 7 to the half over x to 11 halves. All right, they want me to simplify this as much as possible. All right, so, yeah. What do they want in the end? They say simplify positive powers in the end. All right, we'll do it. Okay, so we have the deal with powers. There's 2 rules you need to be super clear on with powers to handle this problem. One of them is, what if you have x squared times x cubed? What does that equal? They add x to the 5th. Yeah, we talked about that one a couple times today. And then what if you just have 1x instead of 2 x's, you just have 1x and both the powers are on that same x? Remember that rule?
You multiply, no?
You multiply, exactly. That would be x to the 6th, yeah. So remember those 2 rules? So therefore, actually, and I need to give you a third rule. What do you do if you have like x to the 2nd over x to the, say, 5th?
You subtract.
Subtract, and whoever's the bigger one is where the leftovers end up. Because really, you know, right, that what that really means. That means 2x's on the top, 5x's on the bottom. They cancel, so what's left over? 3 on the bottom, right? What's left on the top? Nothing. So do I go blank over x to the 3rd? You put a 1, don't you? Yeah, so the shortcut rule, the rule is when the x's or the bases are vertical, you subtract. And if the bigger one's on the bottom, the answer ends up at the bottom. If the bigger one was on the top, the answer would end up on the top, wouldn't it? If they're side by side, rule number 1 is you add, and then number 2, you multiply when there's only 1 base. Okay, so those are 3 important rules. So here we go. What am I going to do now with the 7 and the half? They're going to times, aren't they? Because they're both on the same x, right? Now, that 7 is a whole number, and he's interacting with a fraction. What do you do when a whole number interacts with a fraction?
You make it a fraction.
Yeah, put a 1 in the make it look like a fraction, huh? So it'll be x to the 7 times 1 over 1 times 2, 7 halves. Good so far? So powers outside parentheses multiply powers inside parentheses. And now, what do we do from here? Well, no, they don't want any radicals on this one. Yeah, I know, see, that's where we always got I didn't show you the words. They just want positive powers in the end. They don't care about radicals at all. So what am I going to do here? It's rule number 3 now.
You pass them and then you...
These powers subtract. Remember, when the x's are vertical, they subtract. If they're side by side, they add. If they're vertical, you subtract them. Which power's bigger, top or the bottom?
The bottom.
The bottom. So the leftovers are going to end up on the bottom, right? So it's good.
1 over x.
Yeah, you do. So 11 halves minus 7 halves? Yeah. X to the 4 halves and 4 halves. What's that?
That's 2.
That's 2.
That's a square.
So 1 over x squared is the final answer. Is that too fast? Is that good? One over x squared. See what happened there? So powers outside parentheses multiply powers inside parentheses, and then vertical powers subtract. All right.
Get that one from on the top.
That's because there's nothing left,
Okay.
right? So I want you to see, that's a good question. I want you to see that I'm not doing something new that we haven't done before. Think with me for a second. What if you reduce the fraction 2/6? Just think what you would naturally do. What would you do with 2/6? You would go 2 goes into 6 3 times. Would you go blank over 3? No, we would put a 1, wouldn't we? That's what we always do when the top vanishes. That's not something new. That's what we've always done. And the reason is because really you're dividing by 2. And 2 divided by 2 is 1. We just don't want to show all that all the time. But that's really what's happening. Good there? What do they want? They want positive powers. So they don't want any roots. They just want positive. See how I'm reading the instructions, which normally we don't really have to. Nothing with radicals. That makes sense? They don't want me to do any radical rules. They just want me to make the powers positive in the end. Positive exponents. All right. All right. So, all right, let's start with the top. What should I do with that 1/4 up there on the top?
You multiply.
Yeah, because powers outside parentheses multiply powers inside, right? That was the rule we just saw right here. Right? That 3 outside multiplied that 2 inside to be 6, huh? That's the rule for powers. So the power outside, this 1/4 is going to multiply that 2. Now let me ask you, is that the only power inside those parentheses?
It's a 1 of
There's an invisible 1 there, and he's got to go there also, huh? He's got to multiply all the powers, including the invisible 1. Everybody has a power. If it's not showing its invisible 1, we need to see it now, because that 1/4 is going to hit all the powers inside, including the invisible ones. So what do we get then on the top? That's going to become, remember, this is a whole number, 2 over 1 and 1 over 1, right? Make those whole numbers. So that'll be 2 over 4 and 1 over 4. The bottom I haven't done anything with yet. Is that good so far? See why that became 2 over 4? Okay. Now, 2 over 4. Well,
Let's do square.
here's what I would do next. There's a lot of things you could do. But here's what's going to be best to do next. Never leave negative powers. My concern really is this guy. Because he's got a negative power. What's he going to do? They're negative?
Put it on.
He's going to go right to the top because he's unhappy where he's at. Remember, negative powers are unhappy where they're at. They're going to jump to the other side of the fraction. Well, they will become happy, positive powers. So let that happen first. That really will help you out. So jump that to the top. So then when that comes up, it'll become z to the positive half. And then everything else is still up there. Well, I mean the z to the 2/4 and the x to the 1/4. And the other x is still on the bottom, right? He hasn't gone anywhere. Is that good? So I left the negative powers. They're unhappy where they're at. They want to jump to the other side of the fraction. Then they become positive happy. Okay. Now, what about that z to the 2/4? What can I do with that z to the 2/4? Yeah, just reduce that thing. Let's make it a half, huh? So let me just change that right there. Let's just make that a half. Okay. Now, of course, let's go back and let me remind you these rules. What do we do when x's here are side by side? They add. And what do we do when x's are vertical?
We subtract.
Subtract, and the answer ends up where the bigger one is. Right? Side by side add, vertical subtract. So the z's are side by side. So what are they going to do? Add.
You're going to add.
Half and a half?
The 1 a whole.
1 whole. Just z to the 1. That was nice. But the x's, they're vertical, aren't they? So what are they going to do? They're going to subtract, and to subtract, we've got to get common denominators, huh? So, what do we do to get common denominator? What's a half the same as?
It's 2/4.
2/4. Just make that 2/4. Okay if I just make that 2/4? And now I can subtract these, can't I? Right, when they're vertical, they subtract, don't they? When they're side by side, they add. The z's add. When the x's are vertical, they subtract. Now, which power? The answer is going to end up wherever the power is bigger. It could be the top or the bottom. Where's the bigger x power, top or bottom? Bottom. So, 2/4 minus 1/4.
You get 1/4.
Yeah, 2/4 minus 1/4. So z. And you don't even need the 1 power in the top anymore. It's understood to be there. Z over x to the 1/4. So a few steps in that. Is that okay? Is that making sense? So from the beginning, the power, the 1/4 outside the parenthesis, multiply both the powers inside, including the invisible 1. And then I let the negative power jump. Always do that right away. Let them jump to the other side, then they become positive. Then side-by-side powers add, vertical powers subtract. With a common denominator. No questions? By the thing. So, oh, and they even say rational exponents. Let me write that for you. Simplify with rational exponents. Simplify with rational exponents. So how do I simplify with rational exponents? What do they mean, rational exponents? You know what that word means? Fraction. A ratio is one thing over the other, right? It's a fancy word for fraction. They're basically saying fraction, and what's exponents? Powers, right? They're basically saying, hey, make some fraction powers here, please. That's what rational exponents are, fraction powers. So how do I make, well, here's the rule. It's on the board still. Right? You have a fraction power. The denominator swings into the hook, or now they're going to have us run that backwards. They're having us run this rule backwards. From the hook back into the denominator. Get the idea? So let me write the rule for you. So the rule is if you have a fractional power, A over B, you can, that B swings around into the hook, right? The A always stays put, huh? The top of the fraction stays where it's at. So you can also go vice versa. You can go from the hook back to the denominator. It's either way. You know, it's one uno, whatever. Whoever you're trying to talk to at the moment. They're both the same thing, two different languages, huh? So they're telling me, hey, go to fraction powers. Okay. So what am I going to do with this 4? He goes under the 2. And the root vanishes, by the way. Because once you move that thing out of the root, poof, it's gone. Right? We go from no root to root, or root to no root. So that becomes x to the 2/4. No more root. That 4 left the root and it vanished. And then that's the same as what? X to the half. That's what they want. They're just giving us practice back and forth with these rules. But that's why you got to read the words, because they could have asked me to go a lot of different directions. So that's why I wrote the words for you. Rational exponents, fraction powers.
Oh, okay. So when you move it back, you put it
Under the root. At the bottom. Yeah.
under the exponent.
Yeah. That's right. 17 is going to be 8th root of 6561. 6 to the 8th, is that what it is? X to the 4th. Okay. Same thing. I think they say the same thing, don't they? Usually I have to simplify. All right, they just want me to simplify. All right.
What number? 17.
17. So 8 in the hook, 6, 5, 6, 1. All right, well, I'm going to do the same trick I think will be best. That is, I'm going to swing that 8 back. So, how's that 8 swing back? Well, he goes to the denominator. The denominator of what? All the powers within him. What powers are within him? That 6, 5, 6, 1, do you know, has an invisible 1 power right there.
Invisible 1.
everybody has a power, including numbers. Right? That's 6, 5, 6, 1 to the first power. So what? Well, that means when that 8 swings around, he's going to go underneath that guy and underneath that guy. So it'll become 6, 5, 6, 1 to the 1/8 and x to the 4/8.
I have like a dumb question, but, okay, probably not, but we can't simplify the 4/8, right? We leave it as is.
Oh, we'll make it a half. But there's nothing else we can do than that. Yeah. Does that make sense what happened there? So again, according to the main rule we've been dealing with tonight, numbers in the hook swing into the denominator, don't they? And vice versa, depending on what you're trying to do at the moment. So I swing this 8 from the hook to the denominator and denominator for both those powers. Everybody has a power. If a number or letter is not showing his power, it's an invisible 1. Right? So the 6, 5, 6, 1 has an invisible 1 power, and the x has a 4. The 8 swings down a little bit, both of them. Now, use your calculator. 6, 5, 6, 1 to the 1/8. I'm betting it's 3. So do that in your calculator. I'm betting it's 3, and then this is x to the half, right? Because 4/8 is just a half. So do that in your calculator. Are we good there? Did we get that okay? Well, I just looked to make sure the form. They want me to answer as a radical. So this is root x. Everybody see that's the same thing as root x? Because if you write the root x, there's an understood 2 in the hook and a 1 in the power. That's the same thing. So that's how they want me to give the final answer. Because they never really said rational powers. It's a little tricky which way they want me to go. Is that good?
So the final answer is 3
Root x.
root x.
That's because this 2 swung back around to be the square root of x. All right. So 4th root of x squared, x squared, y squared. Same kind of thing. They're going to say use rational exponents, which means fraction powers, right? So what are you going to do with that 4? Swing it around, huh? So swing that 4 around.
X to the half, y to the half. That's it, huh?
So this 4 is going to have to swing and swing. So it's going to be x to the 2, 4 and y to the 2, 4. Does that make sense? And then, right, because that goes to the denominator. And then can I reduce those fractions? What's 2/4? Half and a half. That's what they want. We good? Let's see if I can. So here we go. So let's do the swing around thing again. So the numbers in the hook, where do they go? They swing under, don't they? What power? Hey, this y is not showing his power. So it's an invisible 1. Well, I'm going to make it visible. So the 5 swings to the denominator. The 3 swings to the denominator. So it's y to the 1/5 times y to the 2/3. Good so far? Now, what's the rule for letters side by side? What do the powers do? Add, right? If they're vertical, they subtract. If they're side by side, they add. So I want to add those. Now, how are you going to add those powers? Got to get a common denominator, huh? So that's going to be 15. Top and bottom by 3. top and bottom by 5. Right there. And so what do we get? Y to the 3/15 plus 10/15. Tracking with me? That's y to the 13/15. Now, I think they want radical in the end. Yeah, they want, so in the end, they want you to change it back to radical when you're all done. So how can we change this back to a square root now? Well, it's all good to hear. This is all correct. This 15 goes where? Back into the hook. And there's the final answer they wanted. And the last one, I'll come back to this. I didn't notice. In the end, they want square root of x, square root of y, which is the same thing as square root of xy. They always want us to change back into radicals on these at the end. Remember, a half power is a square root, huh? So that was the final answer they wanted on 18, if you want to go back to that one. They wanted me to go back to roots. And 19, same thing, back to roots at the end. How we doing? That's all the time we have.